Welcome to the Forest Analytics Landing Podcast. I'm your host, Matt Russell. In this podcast, we'll talk about how data and analytics are transforming the forest products industry. We'll share how a research-based approach to analytics can empower your forestry organization to make better decisions with your data. Hey everyone, welcome to the podcast. And today I want to talk about data analysis. And what I really want to talk about is bad data analysis. And so I'm going to highlight a couple of things that I see as red flags as you're looking through data analysis, as you're reading that report, trying to understand what someone reported on and some of the numbers that they presented. I'm going to share just a couple of things that I've come across from listening to people, watching people, listening to podcasts, watching presentations, reading those reports that are really red flags, I call them, to a data analysis. And so we know that being a good data analyst really requires folks to understand all the techniques that go into analyzing data and how to communicate them effectively. And so obviously people that are presenting research or presenting numbers and data summaries, they've got to have that background and that foundational knowledge. But one of the reasons that I really wanted to provide this podcast is to show that some of the most effective people that use data and that summarize data are actually the people that best communicate those data. And there are lots of different things in the data analysis process that makes a good data set good and a bad data set bad. And so I'll share some things about that here in this podcast. So the first thing I want to talk about is whenever you're reading something and you don't know how many samples were collected. And so the first one is really when sample sizes aren't shown. That should be a red flag to you as you're reading that material or watching that presentation. And so the reason this is important because the magnitude of the values that you're seeing can really be put into context. And so as an example, if you learn that a polling company said that 70% of voters supported candidate A and 30% supported candidate B, you might think that first candidate A, is pretty much a lock to win an election. But if you realize that there were only 10 people polled as a part of that survey, you're going to be more uncertain and you're going to have more suspicion about the usefulness of that poll. And so it's really important to understand how many samples were taken as a part of that analysis. And I think that people that don't present the data, not to say that they do it to be malicious or to hide the results in some way, but I think the people that don't show that number of times or number of data points that they collected, they don't realize that it obscures your interpretation of the results. And so it's a really good practice to always show the number of samples that you take when you're providing a summary of a data set. Really, whenever you're working with the data set, it's just a good practice. And so there are lots of ways to do that. If you're working in a table and you have lots of different variables or lots of different attributes that you collected, it can be as simple as adding a column in that data set or in that table that reflects that data set. Or if you're presenting on, say, a PowerPoint slide or in a report somewhere, in parentheses or somewhere on that slide or in that report, just say what the number of samples was. It's a quick and easy way to better showcase how your data and how your analysis can be interpreted by others. A second one is when you're talking about the measure of variability and how it's not reported. And so I often go back to Nate Silver's popular book, The Signal and the Noise. And so that was really popular around several elections, presidential elections ago in the U.S. That really popularized a lot of the methods used in political polling and statistics. And so the idea was that the signal in any data set, in any ecosystem of interest, whatever it might be, that signal represents what's the trend, or typically we think about it as the mean value or the average. What's that trend going toward? Or as the noise is all of the bounciness around that trend. And so the noise is often hard to weed out to find the signal. And so while the signal is really oftentimes what we're interested in, it's really the noise that's more challenging and sometimes more fun to deal with. And so one of the frustrations that I have is that when you never really are shown a measure of variation or a measure of the noise when you summarize a data set. And so it's a good idea that when you're collecting data from a population to present, sometimes it's the standard deviation or sometimes it's standard error after you collect that data. And so this is really important because it's important to understand how variable the measurements are. If you were to poll people, again, kind of going back to which political candidates they might support, well, it's going to be important to know if you have demographic data as well, to understand, well, how much variability is there in candidate support versus age of the voter or socioeconomic class of the voter or where that voter is located in terms of where their residence is. All of those attributes are really important. The best way to kind of understand that is to also understand the variability of the data that's being presented. A third one is to think about the distribution of the data. And a red flag to me is if the analyst never really shows you how the data are distributed. And so if you know the mean and the variation of a data point of interest, or of a variable of interest, I should say, you have a good information about what that distribution is like. But it's not the complete distribution. And so if you have that complete distribution of the data, that's really important. And so what that means is that not just having the mean and some measure of the variation, but also being able to see it. And typically this is really done well graphically if you can plot the data to see what that distribution looks like. This helps you to identify any outliers that might be in the data, any clustering of points, in certain areas in the data set. And the reason for doing this is it can really tell you if you need to perhaps do other things before you do some statistical tests on the data, or you want to try to transform the data in somehow. If you understand what the distribution of the data looks like, it can be helpful to understand next steps in terms of understanding how the data are distributed. And again, I think the visualizations really help here to look at the distribution of data. If you go back to introductory statistics classes, things like histograms and box plots are really useful to show these distributions. There's lots of newer kinds of visualizations that can also help with this. But as you're thinking about spotting poor data analysis, if you see an analysis and you don't really get a sense of what the distribution of the data is, that ought to be a red flag to you to think about what's going on here. Why am I not seeing the full distribution of the data? So it's something to be on the lookout for. Another one that I see a lot, especially from early career people and especially graduate students, is just displaying too many results. And so this is an indication of a poor data analysis. And so I think as you present more and more things, the ability for one person to catch something that goes wrong or something that seems out of place is far less because it's really hard to digest lots and lots of results, particularly if they're presented in large tables or lots of figures, kind of one after another. It doesn't really seem like it's going to help to answer the question that needs to be answered. And I think a lot of analysts do this because, number one, they don't necessarily know what is the right thing to share. They might run their data through a software and get lots and lots of output, but they're not necessarily sure which is the one summary statistic or output that they really need to focus on. And so they just present all of it. Or they're really lost sight of the motivation for the work. And I think this is a common one too, as people are tasked with just provide us an answer to this question. And if you present a 50-page report with 50 tables rather than a 2-page report with 2 tables, well, it can certainly give the impression that you maybe have done a lot more work. Whereas for me, I really value the data analyst that really trims down the results and really focuses it to the audience. If that's a supervisor that's really interested in something, trimming down from 50 tables to 2 tables may take a lot of time and effort to think about, okay, what is the real motivation for doing this work? But it also expresses the need to understand, here is the valuable information that you want to answer this question to make a decision. And so I think displaying too many results is oftentimes kind of a haphazard way of doing a data analysis that people often do because they've lost sight of the focus of the project, or they're not really sure what the motivation was for the project in the first place. And so a good one there is to, I think also as you're working with other data analysis, to kind of pass back and forth different results that you see. And as you're thinking about putting these into their, quote, final format, whether that be in a report or some kind of website or web application or something, to get a sense from others, okay, what do you think is important here? I think A, B, C are important, but do you think I can just get away with presenting A and B, or should I move on and present it in a different way? And so I think in terms of getting feedback from your colleagues is a really helpful thing to tackle this red flag. Another red flag, I think, is, again, we rely on software a lot to provide all of the information that we might need after we do a data analysis. But I think we oftentimes rely on it too much, to the point where lots of people do a data analysis and then copy those results and then paste them into whatever their document is and then call it a day. And that's a lazy way of doing data analysis, in my opinion. A good data analyst will go through and filter what are the key things from the software output that are provided that I really need to share in this report or in this presentation. And that's going to be really, again, that can take some time to think about what are the most important attributes. But I think then it shows me as the audience member that they've done their work and thought about, okay, they've done a lot of analysis that provide a lot of output, but what is the main thing that's going to be shown here in this report or in this presentation? And so, as I said, just copying the output from software and pasting it into some report you're working on, it's a lazy approach, and it indicates you really haven't spent time thinking about how to communicate your data very well. And so to kind of combat this one, again, kind of lean on your colleagues to provide feedback on what works and maybe what doesn't work in terms of some of the output you're provided. But also have a look at other reports, other papers, other presentations that kind of do things similar to what you're trying to do and that you're trying to analyze. And that can leave you with a lot of inspiration, with some ideas and also some unique ways to present information that can really resonate with your audience. And so again, I think don't just run your analysis and copy the output and put it in your report, but spend some time thinking about how to better show those results in that report or in that presentation. And then the last one I have is about tables and figures. And again, this is something that surprisingly is not taught very well, but it's just kind of something I think people assume we pick up on throughout our schooling and throughout our education. But tables and figures both have their own purpose. I like a mix of both when I'm looking at a report or a paper. The key thing to think about here is to use tables if you want to present data in a compact form, and then basically use those tables and fit them on one page. I've come across a lot of tables that span across multiple pages and have different, lots of columns, lots of rows. And for those kinds of things, you're really almost getting to the point where you're presenting a data set rather than a summary or a table of some value of interest. And so use them effectively, be efficient, be compact with how you design tables. For figures, we use them typically to convey trends and to showcase differences in one variable to another. And so for that, you can also use them to obviously display a more variety of different attributes like photos, maps, and other illustrations, but just use them effectively. And so think about differences between tables and figures and which might work best for the data set that you're using. And so I hope those red flags kind of present some inspiration to you to think about data analysis and how you've seen them presented or how you use data analysis and present your own data. I think there's lots of different things and lots of ways to spot some of these poor data analyses in the future. I also wrote a blog post on this recently that I'll also share in the notes. And I'm always happy to hear your feedback and to hear about any other red flags that you might have. And feel free to reach out to me, and I'd love to chat. Thanks, everyone.
Thanks for listening to the Forest Analytics Landing Podcast. For more information on how data and analytics can empower your organization, visit arbor-analytics.com.